baby lessons, like they're tiny. Don't be alarmed. Don't be alarmed. You're going to see how simple they are. So as I said, this lesson, this lesson is just this one page. It is very simple because it's just a formula. And all the midpoint is of two line segments is if you're given two coordinate points that connect together and make a line, we want to know what is the middle. That's M, the midpoint. What is the coordinate point of the exact middle of this line segment? Which there's a formula for it. It's called the midpoint formula. And it's literally just you finding the average essentially between your two x coordinates and your two y coordinates. So all it is you're going to add your two x coordinates together and divide by 2, and add your two y coordinates and divide by 2. And that's the middle. So for example, with this worked one, right, they said, okay, we have to find the midpoint between A and B, where A is at 4, -1, and B is at 2, 5. So all you're doing is your first coordinate point is going to be x1 and y1. And then your second coordinate point, or the second letter that they give you, that's going to be your x2 and y2. x1 and y1 and x2 and y2 just mean like my first x coordinate point and my second x coordinate point. That's all it means, that little subscript or like the little 2 below it. And you're just going to plug it into the formula. So I took my x coordinates and I said, okay, 4 plus 2 divide by 2, which is going to give me 6 over 2. And then same thing, -1 and 5 for my y's. And I'm going to divide that by 2. And then you see that these can simplify to 3, 2. So you're solving for a coordinate point. That's what you're going to end up with, a coordinate point. And that's it. Same thing with this one, where they gave us C and D. This is my x1, this is my y1, ooh, this is my x2 and y2. And you see, if I add my x1s together, I get 5 over 2. And if I add my y1s together, I end up getting 9 over 2. You could leave it like this in fraction form. That's fine, because it's not like a whole number, so that's fine. Or you could write it as a decimal. Either one's okay with me. I have no preference whatsoever. If you can. That's why I'm like, in this case, you could leave it in fraction form since it's not a whole number, right? You can't really simplify it more than that. Or you could just leave it as a decimal. I'm cool, right? So because it didn't give you an example, I'm going to say you practice this. Just do it in like the little side area over here. What if I told you I want you to find the midpoint between a point A, -4, 2, and B, which is at 6, 8? Can you find the midpoint of that? Using the formula that's on your page. And you let me know what you get. Ding, dong, ding, dong. Where's your pencil? Oh, try it. Okay, tell me, what do you get? Has anyone figured it out? Yeah, Ayla, what'd you get?
1, 5.
1, 5? Okay. Does anyone else get 1, 5? Did you get 1, 5? You got the same thing? Okay, so for those who are still writing, I'm going to catch up. I did the same thing where A is going to be my x1, y1, B is going to be my x2, y2. Oh, thank you, sir.
I deciphered the majority.
Thank you. And I'm just plugging it in to my midpoint. So I'm going to do my x's added together. And as you can see, it doesn't matter which one goes first. We always do first plus second. But even if you flip the order, you would get the exact same answer. Same thing with 2 plus 8 and 8 plus 2. It will give you the exact same thing. Right? So this simplifies to 2 over 2 and 10 over 2, which can be simplified. Those are whole numbers. So anything divided by itself is just going to be 1. And then 10 divided by 2 is 5. Done. How do you feel about midpoint? Easy peasy? Good? Good, that's the end. That's literally all it is. I know, that's why. I'm like, we can like run through this. It does not take long. It's a very intuitive unit of like you're just using a formula. You're just plugging it in and solving for values. 2.2, which is length of a line segment. Sometimes we can't really determine it off the bat. If it's a strictly horizontal or strictly vertical line, you can just count the squares to say how long something is. So if you look at this one, how long is that line segment? How many units? 3, right? 1, here, I'll do pink. 1, 2, and then 3. So it's going to be 3. What about this one going upward? How many units is that? 2, right? 1 and then 2. When it gets into diagonal lines, I can't really count because I could be like, okay, it touches one square here. Now it's touching this square and then it's touching this square. And then it's like, I can't count it like that. The distance is not that great. So that's when we think of like, oh, if I can make this into slope, for example, and do rise over run, remember that thing, right? You can use rise over run. You can also kind of combine it with Pythagorean theorem because it kind of looks like a squared plus b squared is equal to c squared, right? Where this is a plus b and c. So it kind of models both of them. So if we rearrange that whole formula, you're going to get the length of the line segment is basically the square root of its rise squared plus its run squared. So if I want to draw, for example, my rise and run, I see, okay, I'm going over this much. This is my run, which how much did I go across by?
4.
4. Thank you, Adam. And then what about
3.
up? Oh my God. So my rise is 3. There we go. So then if I'm using that formula up above there, if I label this like A and B, for example, as these two endpoints, I'm going to say that AB is equal to the square root of my rise, which is 3 squared, and then plus my run squared. Which, like, okay, you can plug that into your calculator all in one shot, or if you want to simplify underneath, we know 3 squared is 9, 4 squared 16, 9 plus 16 is what? Quick maths. What is it?
25.
25, which is a nice, pretty square rootable number. So AB is equal to 5. That is its length. Right? In this case, we're not talking about like centimeters, meters, kilometers. We have like no units. So like you can say 5 units if you want to keep it like generic, or you can just say 5. That's fine. Right? Easy peasy. If you can't, for example, graph it, like they don't give you a graph, maybe they just give you coordinate points, and maybe the coordinate points are so far away that you can't really draw a diagram because it's just getting too big and you can't count. Or what if, like, for example, your coordinate points are ugly, they're not whole numbers, then it's going to get really hard to calculate how exactly much did you go over by or up by. That's where this second formula comes in, where they're saying, instead of thinking about it in terms of rise over run, think about it in terms of the coordinate points. So now you're just doing the square root of, and you're doing the difference of your x values squared plus the difference of your y values squared. Right? So that is how long a line segment is. And we're just going to practice doing it. So already, page 3, right? So we're going to practice. Calculate the length of each line segment. First step, I need to label x1, y1, x2, y2. So who's who, right? For A, I think I'd call that x1, y1. And B is going to be x2, y2. Right? And I'll remind you that L, or the length of our line segment, is going to be square root of x2 minus x1 squared plus y2 minus y1 also squared. And you're just gonna plug in. That's it. So, okay, if I look at my x values, I always like to follow it with my finger so I don't make mistakes and accidentally put a y in for x, which is what I did in period 1. So I'm like, okay, 2 for my x2, negative 3 for my x1. So this is gonna be 2 minus negative 3 squared. And then same thing for my y's. I'm like, okay, negative 3 minus 8. And again, some of your calculators can do this in one shot. I personally like to simplify as I go, just because what if you miss a bracket or an extra button and you've got a little wonky answer? So like, okay, even just looking at my first bracket, I've got 2 minus negative 3. What happens when you subtract a negative? What happens way back when? That was unit 1. Yeah, it becomes a positive. So this is really like 2 plus 3, which is 5.
Isn't anything squared like positive?
Mm-hmm. So a negative or positive squared will make a positive. And then same thing, negative 3 minus 8, that's going to give me negative 11 squared. And like Adam said, and when you go to square these, you're going to get positive numbers. So 5 squared is going to give me 25, 11 squared is going to give me 121, and when I add those together, I should get 146, which is not a pretty number when we go to square root it. It is a decimal, and it's going to give us about 12.1. Right, so here, rise over run method probably wouldn't have been as great. Voila. How you feel about that? Okay. I would like you to try B. And then we'll do the ugly one with decimals together for C. So try it. Use that same formula. It's those same 1, 2, 3, 4, 5 steps. That's all it is. Use the formula, plug in your values, simplify, and then square root at the end. Some people in period 1 ask me, can I do all the stuff underneath first and then just square root in the end? Sure, if that's too crowded for you, as long as you remember to square root in the end, that's all.
-5 and 3. So first it's like x1.
Holy space.
x2 minus x1. It's plus. No, it's plus, right?
No, it's minus.
No, it's minus. I was right. Oh no.
Maybe we have to make it a little smaller.
No, it's fine. And
Okay.
then here, and then it's plus. y2 minus y1.
I think we're missing some.
Square root equals.
And one
blank.
more little thing.
What?
What's on our brackets? What is he missing? The square. Each bracket is squared.
Square, my fault. And then
Is that supposed to be an upside down L?
I tried to do a cursive L, but it didn't turn out
Did a
real.
little bit of a flip, yeah.
3
Okay.
minus 5
Okay.
and plus 2 minus 6
Okay. And both those things are squared.
squared
And square
squared
rooted.
and square rooted. My fault, guys.
If you hold down the pencil when you're tracing, it'll correct to a straight line.
It's not doing that.
Like if you draw it and hold it. There you go.
Oh, that's cool.
Fun fact. There you go. Okay, now we gotta simplify. So like,
So now,
what is that?
I need a
3
calc.
minus
I need a
-5.
calc.
3 minus -5?
Oh no, I don't need a calc. It's 8
Because the
8.
negative, the double negative turns into a plus. So it's like you're saying 3
Squared.
plus 5.
plus. Let's see. 2 minus 6 8 squared. 8 plus 8 squared. 64 plus 64 is 128.
Okay.
Oh shoot. Equals 128. So then after that, we just square root 128, and I don't know what that is, but. So the length equals 11.3.
Solid. 10 out of 10.
Bro, it looks like a grade 3 handwriting.
That's okay.
No, it's not worse though.
Voila! It's the same steps every single time. I don't know what that letter was. That's an interesting take on a cursive L. Kind of looks like a little bit of like a squid, but it's okay, right? Even with ugly numbers like decimal points, it does not change your formula. So don't get like scared when you see these decimal points. I'm still calling this one X1 and Y1, and this one X2 and Y2. Right, so even if I use my same formula, which I'm gonna skip some steps since we established what the formula is, so I'm just gonna go straight into plugging in my values. If I do y2 minus y1, I'm doing y2 minus
Can you
y1.
switch which is the x2 and y and like x1?
Technically you can, because even though you'll get the reversed sign, you're squaring it, so it ends up positive. So like even up here, for example, if I reversed x2 and x1, I would end up with -5 and +11. But if I square them, I'm still gonna get the same thing. So it doesn't matter if you reverse, right? So okay, I'm gonna do -7.2 minus -5.2 squared, and then plus 4.3 minus -6.4. Oh, see, I did the y's first. Oop. I'm gonna flip the order. I just realized that. There you go, my x's first, then my y's. But again, it doesn't truly matter because either way it's getting added together. but just to follow the formula and be consistent. Okay, this is where you might need a calculator. Mental math is a little harder for simplifying. It's okay. For my first one, what do we get? I get 10.7 squared. And then my second term, this is just going to be -2 squared. Right, so you can plug this whole statement into your calculator. If I simplify that, that's going to leave me with 10.7 squared gives me 114.49, and then 2 squared is just 4. So altogether, this length is going to be the square root of 118.49, which if you square root that, rounding to one decimal place, you should get 10.9. Right, so that is the length. I told you this is easy. It's just formula based. This is like a type of word problem that you would see for analytical geometry, where it's talking about a city map and the distance between, for example, in this case, 2 libraries, and it gives you the coordinate point of where those libraries are located. It wants to know how far apart are these libraries. Anytime it's asking about how far apart, what is the distance between, those kind of keywords, distance, far apart, whatever, it's just talking about the length of the line segment. If this one is x1 and y1, and this one's x2 and y2, you're just using the length formula, right? So I can say length, or if you wanted to use d for distance, whichever one, you're just gonna plug this in, right? And if I do 3 minus, I keep doing the y's first, my x's, so 7 minus 1 squared, and then 3 minus 4 squared, which those are nice, pretty numbers. This is really just going to be 6 squared and -1 squared, which gives me 36 plus 1, or root 37, which so close to being a square rootable number, but not quite. It will give us 6.1. Right, so the only little extra thing to do with this one is like a little concluding statement, just to say like the 2 libraries are 6.1. And then I have to think, what unit did it tell me that I'm working with in this case? Kilometers. So I'm going to be consistent. I'm not going to say 6.1 units, or it's just 6.1, like that's the length. You have to like talk about it in terms of real life. So 6.1 kilometers apart. Look, length of a line segment, done. How was that? Easy. You will have this formula with you on the exam. It will be on the formula sheet. So you don't even have to worry about memorizing the formula itself. You just have to feel comfortable with, like, I know what to insert where. That's it. So the last thing that we're doing together, peeps, hold on. Guys. Okay, the last thing that we're doing together is you're just applying these 2 things together. That's it. So we're thinking back to slope and y-intercept form. Remember y equals mx plus b? What is m? Slope. What's b? Y-intercept. Perfect. And then your slope equation, if you're given 2 coordinate points, is y2 minus y1 all over x2 minus x1, which looks super similar to your distance of a line, right? Or your line segment midpoint, right? You're always at, like, putting your x's together and your y's together. So if we need to find the equation of a line that is specifically passing through these 2 points, right? I've got 3 steps that I gotta do. First thing that I gotta do is I need to find the slope of this line segment. So that's gonna be my step 1. Find slope of AB, right? Which I'm just using this formula here, the m equals y2 minus y1, x2 minus x1, which you can go ahead and label. This one's gonna be my x1, y1, x2, y2. It's okay. Okay, so if I plug this in, m equals, and I'll write the general formula just to start, right? I would say again, this is the only like hard part about this is like keeping track and making sure you're doing the right value. So my y's, -4 minus -5. All over my x value. So I have to do 6 minus 3. Right? This is going to give me negative 4 plus 5, which is just 1. And then 6 minus 3 is just 3. So my slope is just 1 over 3. I'm not going to simplify that. I'm not going to write that as a repeating decimal. I'm going to just leave it. Is that cool? Cool. Step 2 is we need to find B. Like, what is the y-intercept of this line? So, okay, we're going to say find B. I'm going to start this off with using that general equation of a line, y equals mx plus b. I'm going to plug in my slope for m, so that's why it's going to turn into y equals 1 over 3x plus b. But now I've got like 3 unknown variables. I've got y, I've got x, and I've got b. So I have to think, okay, what information did this question tell me? It gave me 2 coordinate points, right? I could use either of those coordinate points to sub in for x and y to solve for b. Remember this way back when to unit 1? No? So, okay, I'm going to, for example, say, let's pick A. Let's just pick the first one. So I'm going to plug in A for x and y. So, okay, I'm going to say my y coordinate's negative 5. So negative 5 equals 1 over 3 times whatever my x coordinate is, which for A it's 3, and then plus b. Okay, negative 5 is equal to 1/3 times 3. What is that? Just 1, exactly. Plus b. And then how do I get b alone? I got minus 1 on both sides. So negative 5 minus 1 equals b, which simplifies to negative 6. Okay, we don't just end there, right? It asks you for an equation. So your last step, or step number 3, is you have to just state your final equation. Right, which you can just use mx plus b. So I'm going to say y equals 1 over 3x minus 6. And that passes through a and b. Your turn.
No.
You're going to do b, yeah. You got 2 points, and you're doing those exact 3 steps again. Find your slope, find your y-intercept, and then just put it into y equals mx plus b form. And that's it. Right, so nothing is new here. We have done all of this. We did this all the way back in September.
Do you want me to write out the steps too?
Yeah, you could, or just say like step 1, if you want to say it. And you can zoom in if you want to. Yeah.
Step 1,
Gotta find slope.
Ines, do you rewrite this like when you post it? Do you rewrite it?
If it's totally unlegible, yes. But otherwise, I'll keep it.
So you're saying that mine is totally unlegible?
I did not say that.
Yes, you did.
I said if,
Yes, you did.
if the solution is unlegible. Lucas. What is that? Oh, calculator.
wait, how do I make it straight?
Hold it down. Here you go. Minus x1. Okay.
And then,
Perfect. Negative 1 minus 5. Yep.
over,
Nice. Okay. So negative 1 minus 6.
and then this would just be, alright, so we got that, which is just negative 2 over 1.
2 negatives. If we divide
So
2 negatives.
2 over 1 was just 2?
Yeah, just 2. Negative 6 divided by negative 3, just 2. Okay, perfect. So we got the slope. Now we need the b value.
Yeah.
Is this guy bothering you?
I don't. So y equals 2x plus b.
And then you can pick either C or D. It should give you the same exact answer for B.
We're gonna use that. C.
Okay.
So y, or no. 5 equals 2 times 1 plus b. So
Perfect, and then we just gotta put b by itself.
Are we going through any more lessons yet?
No, this is the end, just the page after this is the back of it, but that's your homework. So voila, step 3.
just write out the equation.
Hold
So
on, don't flip yet, there's some little bits at the bottom that I wanna just talk about. It's okay, y equals, and then slope.
equals 2x plus 3.
Thank you, sir. Thank you,
Welcome.
Ethan. That was chef's kiss. So yeah, before you flip, there's just this little blurb at the bottom that I just wanted to clarify with you. Thank you. So it's those 3 steps every single time. What? Okay. This little blip at the bottom is the last like topic that we're talking about, which is the only, I think, new thing. It's the only like new thing. I don't think we did this. We didn't do this. Did you do this last year? Perpendicular bisectors? Okay, that's what's new. So we talked about way back in September, Dante, flip. We talked about 3 different types of lines: coincident, parallel, and distinct. What's a coincident line? Way back when?
Is it
Was that what you were gonna say, Dante? Ethan, you gotta say that. Yeah, I said Dante. He was saying it. Coincident lines are identical lines where they're on top of each other, remember? And they're intersecting infinitely at every single point. Parallel lines, what do they have in common? They've got the same slope, different y-intercepts, but they're gonna run alongside each other forever and they're never gonna touch. And then distinct lines, we said, they're just crossing. So they've got different slopes, they're gonna intersect at least one point, that's it. So we know that parallel lines have the same slope. Perpendicular lines, however, are lines that intersect exactly at 90 degrees. So they're at like a perfect cross. If I had to draw, why am I drawing it on there? We have an iPad. Something like this, where they're intersecting and this is perfectly 90 degrees. That's what makes something perpendicular, right? So lines that are perpendicular have negative reciprocal slopes, which I think we did way back when in September, where we just said if 2 lines are perpendicular, whatever the first line slope is, we are going to flip it. So if it's a fraction, we'll flip the numerator and denominator. If it's a whole number, it's going to become a fraction, and you're going to change the sign. So for example, with this one, we said if AB has a slope of 2/3, then its perpendicular line going through it has to have a slope of -3/2. So we flipped it and we made it negative, right? So up here, we were practicing, can I find the negative reciprocal slope? So if I've got a slope of 3, what's the negative reciprocal? But I have to flip it too. -1/3, because I have to flip. What about something like -1/8? I have to change the sign and flip it. So what happens? It's just going to be 8, right? You'll get 8/1, which is just 8. What about like -6? What's that going to become? 1/6. And then what about 1? What happens when you flip 1? It just is going to be -1, because 1/1 flipped is just 1/1 still. So that's still just going to be 1. So the only thing that's changing is the sign. Focus. So the last thing that we're doing today, which I'm going to do this one. Peeps. I'm just going to do this one to walk you through it. And then you're going to do B to practice. And then you've got this homework here where you're going to practice. Right? So that's it. So bear with me for the 5 minutes that's going to take to do this question, because this is the only new thing that you're being introduced to. So we've got the 4 steps here. The right bisector, if we're going to find that, specifically has to go through the midpoint of a line. So it's not just crossing anywhere on the line, it's going through exactly the midpoint. That's what makes it so special, this perpendicular bisector, or this right bisector that they call it. So we have to find the slope of the line segment of the 2 points we're given. We then have to find the slope that's perpendicular to it, or just flip it. That's an easy step. Then we have to find the midpoint, and then we're going to use y = mx plus b. That's it. So step 1, I got to find slope. It's okay, I've got my 2 points. I'm calling them x1, y1, and x2, y2. Right, and I'm going to use slope. I'm going to skip my steps here because we know it's y2 minus y1, so that's going to be 2 minus 6. all over x2 minus x1. That's going to give me 3 minus negative 5. And if I go to simplify that, I'm going to have 2 minus 6 is negative 4. And then 3 minus negative 5, that's 8. What does that simplify to? Negative 1 over 2. Right? Your calculator can also do that. So then if my regular slope is negative 1 over 2, my perpendicular slope, which I'm denoting with what looks like an upside down T, it just means like you're meeting at 90 degrees. What would the perpendicular slope be? How do I flip a half? What would that be? And change the sign. Just 2. Right? All I did was I flipped it so it became 2 over 1 and it became positive. So done. That's my perpendicular slope. How do we feel about that? Perpendicular slopes. Yeah, Anna.
How do you know that it like changes signs? Like, it's just,
Always.
it'll always switch signs. So
Yeah.
if it's positive, it becomes negative.
It becomes negative, and if it's negative, it becomes positive. Yes, Ethan? Yes. Okay, that's it. Step 3, we have to find the midpoint of AB. So, okay, if I find the midpoint, which is denoted by capital M, your slope is lowercase m, right? We've got, I'm going to write x1 plus x2. Are we good? Over 2? Right, and I'm just plugging my same points in, my same values. So, okay, my x values added together, I've got negative 5 plus 3, and then I've got 6 plus 2 for my y's. So this is just going to simplify to negative 5 plus 3 is negative 2 over 2, and then 6 plus 2 is 8 over 2, which altogether is just negative 1, 4. So that's the point that this perpendicular line is going to go through. All right. Is that okay so far? Steps 1 to 3. That's okay? The last step where we actually have to like say what the equation of the line is. Before, we were using like A or B to find whatever the B value was or our y-intercept. But for a right bisector, it specifically has to go through the midpoint. That's the characteristic. It's exactly going through the midpoint of AB. So that is the point that we're going to use for y equals mx plus b. That's it. So y equals mx plus b, I can plug in my slope, which is 2, and then I'm going to write plug in midpoint. So it's always the midpoint if it's a right bisector. If it's not a right bisector and it's any line going through it, you could use A or B. Right? And then we've got, okay, my y value is 4, and my x value is negative 1. So this is really like 4 is equal to negative 2 plus b. And I just want b by itself, so the 2 is coming over. So 4 plus 2, or 6. So therefore, your equation of your right bisector is going to be 2x minus 6. And we can box it. Is there anything through this that you want to run through again, or you want to clarify? Any questions about how I got what value, or why I put input stuff where? Or is this okay? Yeah, Anna.
Wait, why did you put the midpoint on the, so you just plugged in 1 and 4? Okay.
Yeah, for x and y. Exactly. Yeah, Hannah.
Why is it taking 6?
It's plus 6. There you go. That was my bad. There you go. Anything else? So I would like you to try B. You're going to do these same 4 steps for these 2 coordinate points, right? You will get whole numbers for both M and B. So if you get decimals, try again, right? So try it, see what you get, and then I want you for the rest of class to work on these problems, and I will give you your tests and grades back.